Hey guys, good morning. We are going to do section 8.6 today, probability. So, take a minute and write this down. The possible results are called outcomes. The list of all possibilities is called your sample space, and any sub-collection of that is called an event. So, take a second and write this stuff down here. Alright, so let's talk about finding some sample spaces here. Listing all of our possible outcomes. So if you are flipping a coin, one coin is tossed, what would your sample space be? So your sample space for this would be, well, when you flip a coin, it would either be heads or tails. So that would be your sample space. If you're flipping two coins, your sample space, the first one, for example, could be heads and heads, heads then tails, tails then heads, or tails tails. Please make a note, these two are distinguishable. They are different. Flipping a coin and having heads then tails is different than having tails then heads. They are two different outcomes. So your sample space here is 4 different possibilities. So go ahead a minute and try to write down all of the possible outcomes for your sample space when 3 coins are tossed. Alright, your sample space for when 3 coins are tossed are these 8 possibilities here. If you think back to the last section's counting principle, the total number of possibilities are how many the first choice, how many options there are for the second choice, how many for the third event. So in this case, when you're flipping a coin, you have 2 choices. So 2, but you're flipping the coin 3 times and they're all independent. So that would result in 8 possibilities. So that's why there are 8 in our sample space here. Alright, probability of event, please write this down. Notice this notation here is talking about the number. So this is the number of events, and your bottom here is the number of total possibilities there are in your sample space. If your numbers are always from 0 to 1 because the number of events is always going to be less than or equal to the total number in your sample space. So 0 would be if your event can't happen, and 1 would be a complete fraction, so all of your events in your sample space are equally likely, and that's what you're looking for, so that would mean that there's a certainty, 100% chance. So that would be 1, and everything else in between there. Alright, so let's take a look at some probabilities here. 2 coins are tossed. What's the probability that both land heads up? So using our definition of probability, the probability that we are getting 2 heads up would be the number of our event, so 2 heads, and the number over our sample space. So let's think back. Let's look here. We're looking at this one here. Here's our sample space, and we're looking for how many is where 2 are heads up. So that's only this guy right here. So the number of our events with 2 heads up is 1 out of our sample space that had 4. So 1/4. So the probability is 1/4, or you could say 0.25 is the probability here. Remember we said that probability is between 0 and 1. So here's our decimal between 0 and 1. If you wanted to see what N of E and N of S are, the number of events, here's our 1 event here, and our number in our total sample space is 4, so 1 out of 4. Alright, next example here. A card is drawn at random from a standard deck of playing cards. I copied a picture here from the internet in case you needed to see all of the playing cards. What is the probability that the card that is drawn is an ace? So, looking at here, Our standard deck of cards is 52, and there are 4 aces. So that means we have here, we're looking for an ace. So the number of aces, the total number of cards, so 4 out of 52, or 1/13. Mutually exclusive. Take a minute and write this down. 2 events are mutually exclusive if they have no outcomes that are in common. So, meaning their intersection, there aren't any that overlap. So, an example of 2 mutually exclusive events would be when you are rolling 2 dice or tossed. The first event, you are looking for the sum of 6, the 2 dice adding up to 6. And then the second event B is rolling 2 dice a different time and your sum is 9. They are mutually exclusive. So let's take a look at an example here. Write this down. The union of 2 events. If they're mutually exclusive, you just add their probabilities. If they have overlap, you need to make sure that you subtract that, because if not, you're counting that multiple times and you don't want to do that. So here's an example where we're going to be using one that's not, the 2 events are not mutually exclusive. So a card is selected at random from a standard deck of cards. What's the probability that it's either a heart or a face card? Here are our face cards, our jacks, kings, and queens. And we are looking for either a heart or that. So notice that there's overlap in our 2 events that are here. So they're not mutually exclusive. They have an intersection. So the probability A was heart, and B was face card. So the probability of a card being a heart. If we need to look back here, how many were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 out of 52. The probability, this was our A, the probability of a face card. 3, 6, 9, 12 face cards. And the probability of A and B, heart and face card, are these 3 here. So the probability of a heart or a face card is the probability of heart plus probability of face card minus them together. That would total 22 over 52, and that decimal is approximately 0.432. The fraction is the exact, the decimal is the approximate. If you were asked to find the probability of an ace or a face card, those 2 are mutually exclusive. Don't know why this isn't erasing. So the probability of an ace or a face card, here are aces, and here are the face cards. There is no overlap, so you would just do the 4 out of 52 and the 12 out of 52 and add them up and call it a day. 16 out of 52, and then simplify. So just remember, if there is overlap, you need to subtract the intersection. All right, next topic here for probability. When we have independent events, so the occurrence of one does not have any effect on the occurrence of the other. Here's an example. Rolling a total of 12 with 2 6-sided dice, your normal dice, has no effect on the outcome of any future rolls. So when you're finding probability of 2 independent events, you multiply the probabilities. Here's your definition here. So probability of A and B, it's a probability of A times probability of B. If there's more than 2, this rule can be extended to any number of independent events. So if you have 6 independent events, you're going to multiply the probability of each of those 6 together. Here's an example. A random number generator on a computer selects 3 integers from the numbers 1 to 20. What's the probability that all 3 numbers are less than or equal to 5? They didn't say anything about you can't have any repeats, so that means that you are allowed to. So here's the numbers 1 through 20. What's the probability of that selecting one number is less than or equal to 5? Well, we have 1, 2, 3, 4, 5 numbers less than or equal to 5 out of the total 20. So the probability of the random number generator selecting one integer less than or equal to 5 from the numbers 1 through 20 is 5 over 20, so 1/4. But we want 3 integers. So probability of A happening, but we're picking 3 numbers. So we have to do the probability of A 3 times, and we're multiplying them together. So go ahead and finish off this probability. The exact probability is 1/64, and the decimal approximation is written right there. All right, guys, so this is the section on probability. Let me know if you have any questions. Most of it's pretty straightforward, and have a great day. Thanks, guys.